am full of pride to tell you a story about how we brought an engineering solution from way out in the Red Sea to underneath here, saving time, money, and allowing this mega plant behind me to start up on time and within budget.
The Yasref project team was tasked to build a full conversion refinery with a capacity of 400,000 barrels per day. Yasref Inlet Facilities and Pipeline Division was required to install new seawater supply and seawater return pipelines and connect them to the existing utility provider network owned and operated by REFINERY. The seawater was to be supplied using a 2.9 meter diameter reinforced thermosetting resin pipeline with a total length of 3.7 kilometers. After utilization of the cooling seawater, the used water was to be returned to the sea through a 3.7 kilometer, 2.1 meter diameter pipeline, tying into REFINERY's existing seawater return header. For the connection to the existing seawater supply line, isolation valves were available and a shutdown for network users was not required. For the seawater return connection, isolation was not available and the time was instead executed while the network was still in service. This innovative idea was hatched in order to avoid a costly interruption of service for the main network customers. After initial excavation, shoring was utilized using 200 mm diameter micropiles to construct a retaining wall between the pipes. This method prevents excessive vibrations and damage to the adjacent header. The installation of the micropiles included the fabrication and installation of 2 levels of steel boxes and PVC pipes to ensure the vertical insertion of the micropile tension rods and prevent damage to adjacent pipes.
Safety and the protection of existing assets were key considerations for us. Therefore, we felt it was critical that we use many strategies to stabilize the existing pipes and secure the entire area where work was to take place.
A butterfly valve was installed in the new line, with a manhole upstream of the valve for divers' entry. After further excavation around the seawater return line, reinforced concrete pedestals were installed to support the pipe during construction. Pipe work methodology involved the placement of a concentric reducer up against the existing REFINERY seawater return header. After installation and alignment of reducer, specialist laminators applied lamination to the joints and reinforced the existing pipe to form what can be described as a strong T connection. Upon completion of lamination, steel reinforcement was fixed and the thrust block was constructed. Existing pipe operation and service continued without disruption, while all activities took place. After completing mechanical work, it was next the job of trained divers to cut a 2.1 meter diameter opening in the existing seawater return header. The entire operation was monitored by a dedicated execution team from Yasref, the contractor, REFINERY, the pipe manufacturers, and the cutting operators. Precautions were implemented to ensure the safety and reliability of the operation. These included providing dewatering pumps to control overflow, installation of lifelines and emergency lights, secondary emergency exit with ladders and a safety net to catch the divers at the secondary exit. The team also performed life safety drills in order to ensure the safe and effective extraction of divers during an emergency. During the cutting operation, teams of 2 divers entered the pipeline through the designated manhole and used pneumatic grinders to cut an opening in the existing seawater return pipe. The early stages of the cutting process took place in a dry environment. As cutting progressed, hot water from the seawater return line began to enter the new pipeline. As water flowed in, dewatering pumps above ground began working to slow the filling of the line. At this point, it became a race against the clock to finish cutting before the water could overflow from the manhole. The entire cutting process took approximately 7.5 hours. During this time, 2 teams of 2 divers worked in 20-minute shifts to complete the cutting, as fatigue from the heat of the water made longer shifts impossible. Once cutting was complete, the divers exited the pipe, leaving behind a circular cutout after the valve. After the butterfly valve was closed, the circular piece was cut into 3 sections and retrieved through the manhole. After completion, the valve remained enclosed until operation of the new pipeline began.
The safety preparation made it in advance were very detailed, and that made us all more comfortable.
The Marafic seawater network remained intact and functional, and there was no impact on other users of the network. The SWR time can be considered as one of the major challenges faced on the project, and its completion is a great achievement that will be engraved in Yasref's history as a remarkable success story. Today, this pioneering methodology is patent pending in global patent offices and on its way to final approval as intellectual property owned by Yasref.
In the end, it was a total team effort, saving chemical complex outage, which would cost more than $200 million, while also safeguarding this mega project scheduled startup date.